I'd like to welcome all of you. As I see, I think we're completed now, and my technical problems, my headphone hasn't worked. So that good afternoon from my side, and welcome to our online seminar, MBSE Mastering Complex Development Easily. I'm happy to see customers, long-term partners, friends, and a couple of new interested persons within the virtual room or under participants. My name is Viviane Zimmermann, and as a head of business area, I'm responsible for customer development in the industrial sector and ongoing projects and programs at my customers. Since 2007, I've been involved in more than 100 projects now with clients in designing innovations, setting up frameworks and organizational development, as well as creating a customer experience for our clients and their clients. With me today is Stefan Schlichting and Tobias Wigger, who will mainly present the content today. And for that, I'd like to hand over to Tobias to introduce yourself.
Yeah, thank you. Hello, everyone. My name is Tobias Wigger. I'm a manager at Unity. I'm mainly doing systems engineering in all shapes or forms, involving most of the time MBSE aspects or MBSE approaches. So I'm doing that for more than 8 years in various industries. So yeah, I'm looking forward to the seminar.
Yeah, and my name is Stefan Schlichting. I'm, as Tobias as well, a manager at Unity. I started at the beginning of last year, and my main focus is also on systems engineering, mainly also in the medtech industry. And as some of you know, I'm also quite heavily involved in the overall topic of interoperability of devices. And this is also related to what I would like to say about me. I always think about data and how to use it on the inside and outside of systems. And now back to Viviane.
Thank you. Today, what we would like to do today is actually guide you through a short MBSE journey, where Tobias will first explain a little bit the context about MBSE, what is MBSE, and then Stefan will actually give you or show you a real-world use case by a practical example where he used MBSE to actually innovate a product. And I'll wrap it up in the end by a little conclusion about implementing MBSE and what results then in the end in a Q&A session in order to end up with our online seminar at 5 o'clock. All our experience that we will share with you today basically are based on well, the close cooperation with scientific institutes and also various customer projects. And as you see here, we did implement, set up MBSE and systems engineering across several industries and several companies. And all this experience and knowledge we have, we actually gather together in publications as well, which you also can request via our website afterwards or even contact us directly in case of interest. Before we actually start with the seminar content-wise, I'd like to emphasize some general information. If you have any questions during our seminar, I do see the chat function, question function is used already quite frequently. Please feel free to use the chat function at any time. Stefan will consolidate your questions in the background, and we will then answer them at latest during our Q&A session in the end. And additionally, we have 2 survey blocks, one within the presentation and one in the end of the seminar. And we're looking forward actually to your participation in both blocks, especially in the end, where you will guide it through immediately after the seminar ends. So please participate. We are always happy to gather some feedback from your side as well. And last but not least, the session will be recorded, and the presentation as well as a recording will be provided to you afterwards. And now I wish you a very fruitful and interesting online seminar and hand over to Tobias.
Okay, so Let's start with a survey. So how familiar are you with MBSE? Please take a minute to record your answers to give us an impression of where you're standing in MBSE. So yeah, so we get further in the seminar. All right, so on half of you are starters, some newbies and some more on the professional side, so it's a healthy mix. So yeah, let's get started and see what would yeah, let us present MBSE from our side. All right, so let's start with a little context, what MBSE is and what MBSE is not. This is the usual slide about rising complexity in product development, essentially. In this case, it's an example from MedTech. In MedTech, especially, there's the interoperability challenge where you come from standalone devices. You get more information availability in these contexts, and the information sharing, information distribution is getting more complicated. So you go from some visualizations with standalone devices to assisted care, where some systems make some suggestion what to do, to guided care, which essentially guides the user, the operator along the way up to autonomous care, where these systems essentially do a lot of tasks for themselves, and this of course requires a lot more context for the individual systems, especially in a heterogeneous environment, right, where not every system is from the same vendor. So we're talking about, as Stefan is an expert there for interoperability standards and stuff like that. So and you can see these complexity increases in a lot of industries, not necessarily only MedTech. You see it in automotive, you see it in other industries, that interoperability, so internal complexity of systems, but also complexity as far as the interoperability with the system elements, yeah, gets more and more complicated. So that's definitely one driver for systems engineering in general, not necessarily only model-based systems engineering. As far as systems engineering is concerned, what we always like to point out, one of the main emphasis on systems engineering is so-called front loading, and the slide that I usually use to explain why front loading is very useful is this one. Essentially these are two curves which depict the defined costs. So the costs you are essentially defining for your product, what the shape, so architecture, shape, requirements, and so on, versus the cost you're incurring when you're building up prototypes and building up the system in production and so on. So then you can easily see that by end of development phase, you have around 90–95%. I'm not arguing on specific numbers, but most of the costs, most of the definition has taken place, of course, and therefore there's a very few. There's not a lot of room to improve further after all these costs are defined, all these decisions are taken. So it's to essentially push a lot of the specification work, do a systematic specification very early in the concept phase and in the beginning of the development phase, incorporating all relevant stakeholders, doing interdisciplinary work is very relevant and very much needed. And if you look at systems engineering from our perspective, this is our crowded slide of systems engineering in a nutshell, right? For us, and when we talk about systems engineering, there are certain drivers which drive the application of systems engineering, or the need of systems, the need for the application of systems engineering. So, for example, as I said in the previous slide, right? So systems of systems, more interoperability and more connectivity, the whole volatility and agility scheme. So faster change cycles, changing requirements over the life cycle of a particular product. So how agile the system architecture itself has to be, and so on. Different business models and That's, for example, that's nothing new to MedTech, changing laws and regulations. So these are all drivers. And then there are certain pillars which essentially define systems engineering, right? And these pillars are the system structure, so a holistic system view from systems of systems down to system element level, having a holistic structure view on the system, which essentially is fed into processes, methods, and IT. So I think the V model is I think it's very well known. There are some certain ingredients with requirements management, architecture management, configuration management, integration of V&V, which are all supported and all carried out in synchronization with domain disciplines, which are the founding blocks of our systems engineering approach. And this, of course, has to be supported by engineering, IT, and so on. Nevertheless, it's still having a structure and process and methods in IT is nothing without an organization and competencies with your people. So in the end, it's all about getting your people to use the systematics and employ it. So you need some organizational, you have to have some organizational homework for roles and responsibilities and so on for, and you of course have to cater for the competencies needed, right? So systems engineering qualification as well as methods and tool qualification. And this all in essence to reach some goals, right? So early V&V, so early virtual verification and validation, the whole holistic right first time goal. Of course, reaching that with a optimal system design, being traceable and compliant, and last but not least, making sure that customer value and user experience are paramount. So that's systems engineering in a nutshell, and for us. And why is that important? Well, because model-based systems engineering is a part of systems engineering, right? So MBSE itself is nothing more and nothing less than a formalized application of modeling to support system requirements, architecture, design, analysis, V&V activities, right? And it starts within the conceptual phase, design phase, and continues. It potentially continue throughout development. It could continue throughout development and potentially later life cycle phases. So it's a fairly old definition, but again, it's very important to contextualize MBSE in systems engineering, because MBSE is something that's not possible, or it's not really as effective as it is within systems engineering. So if you, I'd like to say that the main function of systems engineering and essentially any development methodology is to facilitate communication. In the end, you're always talking with people. People have to carry out the functions, and everything you do, directly or indirectly, with methods is there to facilitate communication between all the parts of a development project. So how can you facilitate communication? Well, MBSE is something that supports that. I'm not saying, and that would be a lie. We're not saying it's the only solution or the one-size-fits-all solution. But it is a planning systematic for the specification of complex systems. It helps you to structure, maintain, and trace complexly related information, and therefore, as of its nature, it operates as an information hub. But as I alluded to, it's as important. It's not only important to know what MBSE is and MBSE is capable of, but it's also very important to say what MBSE is not. So first of all, MBSE, no matter what anyone tells you, MBSE is not systems engineering. Systems engineering is the overall umbrella, the methodology, the true and tried methodology over decades. MBSE is a supporting facilitator for a successful conduction of a systems engineering effort, right? So and therefore MBSE is also not an automatic guarantee for project success, far from it. And on the other hand, it's not a toy. So modeling everything doesn't fit the purpose, right? So it's about a measured approach. So if you look at MBSE, there are essentially three main pillars which are necessary for a successful MBSE application. So and this is essentially the method, language, and IT tools. So starting with the method, which is which gives you essentially the effectiveness. So you're doing the right thing. What kind of information are you putting in a MBSE model? How are you relating that information? How do you get this information out for facilitating specific purposes in the end communication? In order to be effective at that, you need a language. So in this case, the de facto standard for that is SysML. There are a lot of different vendors using it. The language is extended. There will be version 2.0 in, I think, 2 years something. But you need the meta model. You need the meta model to express yourself. And of course, you need a tool then, which gives you the efficiency. So you're doing it right? But it's always the database aspect of MBSE doesn't make sense without a tool. But nevertheless, you should always talk about efficiency first. So what are you going to do and what the right thing to do is, and then you think about how you can make the process of doing the right thing very efficient. So what is a model essentially? Well, I'd like to direct your attention to the right side of the slide. So a model of A is used in place of A to answer questions about A. Nothing less and nothing more than that. It's a model is a abstraction of reality. If the model would be reality, there's no sense for having a model. Then you could look at reality, right? A model is used to abstract reality away a little bit. And the overarching theme here is decide about the questions you want to answer, right? So, for example, how is your system composition doing? What interfaces do we have between components? What are dependencies of subsystems? What are my external interfaces? How they are related to external systems or system elements, right? What about traceability? So how does the architecture of the system satisfy the allocated system subsystem requirement, including those relating to risk control, in the sense that they're very, this is especially important in medtech. So be mindful about the questions you want to have answered by the model, and with these questions you approach the builder of the model. And this is, at least conceptually, this is the difference, right, between a document-based approach on the left side, where you have a lot of documents from very different domains, from project management and manufacturing, CAD, so more on the domain engineering, like software engineering or mechanical engineering, analysis tools, and so on. And you have documents and you have implicit dependencies between documents. So when one document changes, you have to make sure that all the implicit or explicit dependencies are changed. So it's a lot of effort. It can be done, but it's a lot of effort. And the basic approach of a model-based approach is essentially having a central system model, at least logically, one system model which integrates all this information and makes sure that all this information is traced to one another, and you can essentially walk these traceability chains up and down. In reality, of course, this doesn't necessarily mean, or doesn't necessarily need to be one particular model, but the basic mindset of a model-based system engineering approach is that you have this system model, this database where you can put in and link all this data. And if you look at MBSE, the investment and gains and at effort, there's no doubt that there is an investment associated with an MBSE introduction. How much of an investment that is depends entirely on your purpose, how far you want, what the purpose is you want to use it for, and especially how much of reuse you are expecting from such a model-based approach. So if you look at this graph essentially describes traditional systems engineering effort through phases versus MBSE efforts, and you can see there's a bump in the front, right? So there's a investment for relating to process definition, infrastructure costs, so getting licenses and train your people, but also especially model development, model verification, curation, and configuration minutes. So there's an initial hump that's necessary to get up and running to an MBSE, at least if you do the full-blown approach. So the height of the hump can vary depending on what you want to do with it. But there's also factors related to MBSE gains. So like stuff like early defect detection, especially reuse, especially for more complex systems. And if you're talking about product lines, right? So having an initial investment for the first application of a product line, and from there, going from there, reusing a lot of elements and doing impact analysis on changes. So there's a lot of reuse potential there. Risk reduction by that, as you have better traceability chains. If you are designing your model structure in a good way, you have improved communication. There's a potential for usage in supply chain. I talked about product line definition, and of course, last but not least, a well-structured model, and with some clever enhancements, you get a lot of standard conformance and traceability and documentation from it. So, and as the information, the connection information is in the model, yeah, there's a lot of potential to be gained. So, before we talk a little bit more practically about MBSE, I would like to ask you for the second survey. So, what, from your point of view, what is your main driver for applying MBSE? So, there's a yeah, there's a fairly even split, right? So about not exactly a third about improved communication, improved quality, and improved productivity. And these are definitely gains you can achieve with the systems with an MBSE approach. How much there is to be gained, essentially, yeah, depends a little bit on the specific circumstances, of course, but the potential for that is definitely there. So what does MBSE in reality mean? Model-based systems engineering supports the systems engineering RFLP approach. So requirements, functional, logical, physical architecture. By doing that, it facilitates the structured specification. So left side of the view model, structured specification of a complex system. And it also serves as a interface to low-level design definition, so domain engineering, right? So it gives you the ability to structure the information in a way that the different domains can work with it. The communication is established. Another potential of a MBSE model is essentially that this model is used as a blueprint for development, data depiction, and for other artifacts like digital twin stuff and something like that. So the model has the potential to be used as a guiding entity, let's say it this way, as far as the structure of the system is concerned. This is a simplified depiction of what we use as an MBSE framework. I won't go into much detail about that. As you can see, there's the RFLP approach is present with some further additions. And if you look at a little bit of traceability, you can see that such a traceability, there's a lot of traceability to be established as long as it makes sense, right? So do as much traceability as you need and as less as you can get away with. So there's lots of different artifacts, but the language itself and the method itself allows you to describe systems in a fairly precise way, let's say it this way. The good thing about this is, depending on your purpose, your exact purpose, you tailor this approach. As tailoring is, of course, very prominent in a systems engineering approach, tailoring applies to MBSE as well. So you can, for example, you can have I've done projects where it was just essentially a little bit of a base architecture, doing a functional architecture, and then doing a high-level logical and physical architecture, because that was always needed for facilitating communication. This wasn't a project where it was embedded in big processes. It was more of a coaching project, but nevertheless, the approach supported it, and the elements that got out of the model were enough for people to facilitate the further development. Another way is, for example, you're looking at context definition. So what is my system in the context of a system of systems? What are the main use cases deriving from the systems of systems, putting that into a functional architecture and a high-level logical architecture, right? It's just another scope, right? And it's not necessarily, to be perfectly clear, MBSE in itself does not necessarily require, for at least for a coaching application, doesn't necessarily require full-blown processes and defined roles in the first place, right? Of course, if you're in a big organization and you want to harvest on the possibilities and potential of MBSE, this is something that you need to look at. But MBSE is, even on a small scale, a model-based approach is a very useful tool. And this is another example where, for example, starting with system requirement as an input, and then doing the whole, more or less the whole 9 yards from requirement engineering, functional architecture, logical architecture, and then doing a high-level physical and domain architecture. One last aspect before I hand over to Stefan for showing you a practical example. One aspect I want to emphasize is this whole single source of truth aspect of MBSE. So this model and these repositories do contain a lot of different information, which is complexly connected. And with a little bit of skill and the right tools, you can get a lot of information structured the way you need it, right? So, for example, getting specification trees, like in different Office formats out of such a model, right, is a stopgap measure, because if you don't have full processes and complete data flow through all the organization. But you can use it for target costing aspects. Of course, there is direct model element exports, like different diagrams and stuff like that you use for communication. Interface specification, which come out of the model, can be composed. Documentation, of course, especially for legal purposes, which can be automatically generated from such a model. So there's a lot of potential using a MBSE system, an MBSE approach. And this is not, and again, it's not necessarily tied to having a big organizational change in the first place. Starting small can be a very good idea. Starting small and demonstrating the value of such an approach. So that's why the conclusion is down there at the bottom, right? So the MBSE approach interfaces well with even traditional information structure. It's just a question of customization and determining the questions you want to have answered. Right? All right. So now I would like to hand over to Stefan to show you a little bit of a practical example.
Thank you very much, Tobias. What I would like to show you today is an example where we used a very tailored MBSE approach for one project that we did last year mainly. It's the well-synchronized project, which was basically in the context of a challenge, the well-synchronized challenge from Fraunhofer and Munich Re, and where the goal was set out to develop a ventilator for COVID-19 patients, as well as an oxygen concentrator, because you do not have always oxygen from the wall supplies in the regions where we wanted to deploy this ventilator. And you could imagine we started with the project, I think probably in April. And the first time I basically met my team colleagues was during the prize giving ceremony where we won this challenge in August. And what we basically did using the MBSE approach was in the first place to communicate between us different parties in the development. So most of the developers were actually sitting in Munich. I'm sitting in northern Germany. So we needed to communicate and align different aspects of what kind of system we actually want to build, what should be the parts inside of the systems, what are actually the needs that we try to address in the challenge, and so forth. And finally, we actually used a lot of the artifacts that we internally use to, for example, discuss, okay, which risk control measures do we need to implement, which standards do we need to consider. We also use to create a documentation for the discussion with certain authorities in the selected countries. And as you can see here on the right side, this is a picture from South Africa, where finally the prototypes were deployed and tested in a clinical setting. So we also there use the documentation basically for the emergency use authorization. And maybe Tobias, you can go to the next slide. What I would like to show you now is a certain view of the model that we prepared. And I will switch in a few seconds over actually to the tool that we use so that you can see that it's not only pictures in PowerPoint. The main aspects why we did it, as I mentioned, is that we wanted to improve our collaboration and communicate and build a holistic understanding of what the devices actually were. So we first started, of course, with a functional structure. As you can see it here, the red ones are basically identified functions that we need for risk control measurements. And Tobias, maybe if you can switch to the next slide. What we then, of course, also did, we not only did the structure of the functions, we, of course, did also the functional chain, the flow chain. For example, here, how the gas is supplied and enriched or filtered, and then O2 enriched air is basically delivered from the oxygen concentrator to the ventilator. And maybe Tobias, you can switch to the next slide. What we of course also did is we created a logical system structure. We identified the systems that we really need here. And if you go to the next slide, we of course did also allocate all the functions that we have identified in the functional architecture to the different system elements from the logical architecture. And what I would like to do now is actually I would basically show you the same content again, but how it really looked in the tool that we used, and show you a little bit more how that it's a little bit more interactive. So I'll take over the screen from Tobias. This might take a second, but then I can show it directly to you. So you should be able to see my screen now. And so what we use as a tool, it's basically Cameo Systems Modeler. And exactly the diagrams that you just showed here are directly out of the tool. This is, again, the functional structure that we had outlined. We also have here, in this case, another flow, how the oxygen enriched air is actually supplied. Then we do have here again, the logical system architecture and also the allocation table. What I didn't show so far is in the slides was, okay, we also of course mapped how the flow is actually between the logical elements, in this case of the oxygen concentrator. And I think one of the aspects that I wanted to highlight here is really that, of course, now everything is in the model, it's connected, all the traceability is established. I think one of the views that I really love and use very often is that, for example, if we now look at the oxygen concentrator and its parts here, we might really want to look at, okay, what kind of subcomponents are there, and I can now drill down basically through the model and see, okay, for the component dirt filter, there are certain functions applied. In this case, maybe filter the gas and protects against emitted physical effects. And if I drill down more to the filter gas, in this case, we also actually see now here's an example to a certain set of requirements that are actually linked to it that we wanted to fill and that we said is relevant before we can really transmit it or put it into action inside of the hospitals. For example, that we need to filter biological contaminants, dust, and of course other stuff, and that is specified, of course, in more details in the requirement specification. So this was just a short exercise so that you see it's not only PowerPoint. This was what we use basically to discuss with our team as well as with the authorities how the product works or the systems work that we developed and how we could use it. And I would like now to hand over back to Tobias, and so that we can have a look at the final slide. And maybe Tobias, you can switch to the next slide already. And for this, for the conclusion for today, I basically hand over to Viviane so that she can draw the conclusion.
Thank you. Thank you. Okay, well, we heard a lot about MBSE, how it actually looks like, and a lot of people, a lot of customers ask me then how to actually implement MBSE. And for that, we'd like to show you an approach as a blueprint. Most of the companies, or most of the clients actually that I deal with, they always come from the point where they say, okay, systems engineering, what is our target picture and strategy? So that's their starting point. Even for MBSE, you need a clear picture about that. What do you want to achieve with MBSE? And we recommend on that, start really simply with identifying the common errors, identify communication breaks, and take this as a starting point for the current projects you actually deal with. And later on, go on a stepwise approach. Then secondly, to actually apply those learnings from the first phase when you're clear where to head on, to apply those in pilot projects and derive measures on that. And usually what is really recommendable for applying MBSE in the reality is actually establish the architecture. Start with the architecture development and the requirements engineering. Use that as a starting point then before you actually start scaling and implementing MBSE across the entire company. When you gained first, let's say, implications and measures, and you gain some experience in using MBSE methodology, you can actually use the methodology to then implement or integrate them into the rest of the processes, the systems engineering processes itself, in order to scale it up, to learn more and more. And as you can see here, it's more of kind like an agile approach. So implement it, learn from it, test it, and then scale it up to further more processes. And then of course you have with 3B, 4 and 5, let's say the scaling on that. Then of course after that, when you learned how to deal with the rest of the processes, you might need adaptations on the roles in the organization. You need to modify roles based on that. And then later on integrate them in other disciplines, like for example, the simulation or the validation verification part. And then in the end, at the last point, to have an overall transformation and to introduce it over, let's say, across the entire company. I think this is one of the main aspects on here. Don't try to conquer the world in one go, because this is also a kind of like MBSE for most of the parts within the organization is more kind of a change project, because you have a different approach on, let's say, improving your collaboration within the product development, and not to see it only from an easy component side, but let's say from a system perspective and a system view. To conclude it up in the end, just to highlight what you heard today, and Tobias, maybe you could go on the next slide for that. I think my colleagues Tobias and Stefan, they actually mentioned a lot of that, but just to highlight it, I think on the left down side, communication is everything. I mean, basically, it's not only about a tool. When you talk about MBSE, it's not only about a tool or only about a methodology. in the end, the communication and the way how to improve actually product development where MBSE helps you is basically one of the main aspects and benefits MBSE can bring to your company or to you. Secondly, it helps you to focus on the essential, not to, let's say, have it overall, and that actually relates to the third conclusion. It's not a synonym for all in. Don't try to use MBSE and try to actually solve every problem with it. Focus on it. Be clear about what you want to solve with it. And then MBSE is a really good and powerful tool or methodology to actually improve your current situation. The next is front loading. And the systems engineering basically is a front loading, as we heard from Tobias, it's a change of mindset. And don't underestimate the change of mindset, and have some measures in place as well where you really deal on how to actually change the mindset itself. Be also aware that MBSE as a standalone, integrate that with your product lifecycle management solution or your tool chain around that, because this is something I really see in reality, that most companies, they have two kind of programs. First of all, dealing with the systems engineering or implementing model-based systems engineering. On the other hand, implementing the product lifecycle landscape. And most of the time, it's not really interacted or interviewed together. And the interaction between those two programs is really, really important in order to make it sustainable, in order to make it successful as well. And then the last two ones, of course, as mentioned already, many disciplines can participate, especially in the information flow. And of course, the effort must be reasonable, so don't conquer it all at once. It helps actually to tailor at the project level, and it makes it a little bit, the effort more reasonable in comparison to the whole project or the whole complexity of the project. So for that, we are at the end of our online seminar, but we have a couple questions actually addressed before that. And for that, I'd like to hand over to Stefan.
Thank you very much, Viviane. And if you have any further questions in between now, just put them still in the questions and we'll try to answer them all. And let's see. So we do have one question that is I would maybe like to address to Tobias. This is okay. What are typical do's and don'ts when starting with an MBSE approach? And I think Viviane maybe already touched on it in her summary slide, but maybe Tobias, you can say maybe the top 3 do's and don'ts from your perspective. And you are still muted if you say something.
Thank you. Yeah, be clear about your goal. That would be the first do. And so be clear what you want to achieve with it, and then don't conquer it in one go. Do it step by step and prove the usefulness. And please don't, as far as don'ts is concerned, please don't approach it in a way like we're buying another tool to improve. We go from this tool standpoint in order to implement MBSE. It's without the process and the methodology, and especially the systems engineering mindset, an MBSE approach usually falls short. So think about how to establish effectiveness in the first place, and then think about different tools, integration in IT landscapes and stuff like that.
Very good. Then we do have one question which is regarding the MBSE common database, the one source of truth. I think, Tobias, you mentioned it. Will that also include CAD models and related simulations like structural and fluid dynamics simulations included in the models? And how is the traceability and how are they linked together maybe?
From my point of view, let's say it this way. Storing structural information like domain development artifacts like CAD models or analysis or software and so on is essentially the main task of a PLM system. So the potential of the integration with an MBSE, with a model-based approach from the development specification point of view, is that you can use the model and the artifacts to structure the data storage essentially when you're in your PLM system, and therefore you get a traceability. But the solution to that is with the PLM vendors, that they integrate these modeling artifacts so you can get a seamless workflow. And again, it's not, and if you do that, then the potential grows even further, because it's not then only about essentially attaching domain development artifacts like CAD models and stuff to the structure, but the model itself can also serve as a blueprint, for example, for in the context of configuration management for digital twins. So as a blueprint for storing certain information in the later stages of the life cycle of the system.
Okay. Then we do have another question, probably also directed to Tobias. You said that MBSE requires an extra effort at the beginning of the life cycle that is repaid after. Is that true in general for every new project, even if you are using MBSE productively already? Or is that more related to the first times you approach SE with MBSE?
That's more related to the first time you use it, right? Because when you're trying to introduce an MBSE effort in your development workflow and your processes, you have to establish the integration into processes. You have to train the people. You have to invest to get tool support and so on. So it's more related or much more related to the first time of application. The more intelligent you structure your system model, the more reuse you get out of a system model, and the more you're thinking for further applications or like product lines and so on, the more you're not talking about redefining entire architectures, but or not necessarily really redefining complete architectures, but doing impact analysis and changing elements of it while maintaining full traceability, or the necessary traceability, I would say. Not full is not a good word there, because you do have a traceable you have traceability as much as you need. So it's more related to introducing it in the first place. But of course, this also, how much that is, of course, also depends on a lot of different factors, right? What systems are you modeling? How many people are involved? What are the questions you want to actually answer with the model? So it depends.
Very good. Then there's one question related to more systems of systems, systems of product, and how could MBSE help there if, for example, there are different vendors, manufacturers that contribute to that system of system? How can the models be exchanged in this case? For example, maybe they have different tools or whatsoever. Do you know a solution for that, Tobias? Is there interoperability also between the MBSE tools?
So there are certain exchange formats, right, between requirements and MBSE tools. There's OSLC, there are other standards, but I wouldn't, at least from my point of view, I'm not the biggest expert on the interoperability standards, but I wouldn't call it a completely solved problem right now. Let's say it this way. There is also an open question, but it's from my point of view, it's not a completely solved problem right now.
Yeah, that's also my impression, at least from my experience. I didn't try the latest version of every tool, but I haven't seen a very good solution yet, maybe. Then we do have another question that is related to what do you recommend if you discover a hands-on mentality with your customers? So a mentality to start implementing immediately and derive documentation afterwards, or how would you address if you find such a mindset at a company? How would you structure your MBSE approach, I would say, basically? And maybe we can hand this over to Viviane. What would be your recommendation?
My recommendation would be actually start, let's say, with very close use cases for the MBSE, as mentioned, the hands-on mentality and the documentation. But I would always recommend your learnings and the way how you actually proceed to document it by, let's say, directly while applying the methodology during a project, a pilot project, for example.
A quick add to that. Hands-on mentality is something from our point of view. It's a very good thing. So the experience shows definitely what Viviane said. The experience definitely shows that it's you can get a lot of gains even from essentially diving into it. Right? It's as long as you have a necessary methodology in your mind, right? So of course it doesn't help to model something. There has to be a measured and methodological approach. But then hands-on is a very good thing because it's not about talking about it, but it's about doing it and solving actual problems. So we very much embrace hands-on mentality with our customers.
Very good. Tobias, then we do have another question which is related to if you can elaborate on the relation between product line engineering and MBSE.
MBSE can support in the context of product line engineering. In the end, it's about architecture, right? So a lot of PLE is about architecture. So structuring your or specifying your system in a product line centric way is the key, and MBSE supports that. It's and in the end, MBSE there is just a tool, right? So the PLE is in the context of systems engineering is the methodology, what we want to achieve and how much we want to reuse, right? And MBSE helps you to structure that information in a reusable way.
Very good. Then we do have another question, which is related to digital twin and MBSE. Is MBSE a starting point to create a digital twin, or are they actually both unrelated, or how do they relate?
From our point of view, it's a blueprint. So they are the model itself, the blueprint of the system, the architecture of the system. So all the physical architecture of the system or a derived structure from that is a blueprint for essentially the elements of this architecture are an anchor, and you can hang information on these different anchors. So therefore, MBSE is a starting point, and it has the potential to kick off information structure that resembles digital twins in different stages of your life cycle. Right? So that doesn't mean that that will definitely not mean that the full model structure is always present in all different phases of life cycles, because you tailor you take from the model structure what you need for different life cycle stages, right? But yeah, it definitely has the potential for structuring that approach.
Then we do have a question regarding the methodology. I don't know, Tobias, if you have any experience with OPM for the object process methodology, which is another modeling language, I assume. So I don't use it.
No,
I have to admit.
No, I don't use it. Sorry.
And then we do have a question related to the tools and what they support. So for example, will the IBDs or N2 diagrams be included inside of the MBSE tool? That's probably something for you.
Yeah, for the tool we use, they are. And they are indispensable in structuring the information and giving you giving you the ability to view the information from different perspectives. Right? That's the beauty of the tool, essentially, right? It sits on top of a big database, and you can derive your views depending on the necessities you have in that second, right? And the answer to that necessity can be a block diagram or a relation map or a n-square matrix or a whatever you want, right? So it's a structured table. So it's that's the beauty of a good MBSE tool, that it allows you very easily to capitalize on the connected information in the SysML database.
Perfect. Then I think we have time, maybe 30 seconds for one last question. I think you showed it in one of the slides. Is there a connection between MBSE and controlling?
Well, you could use, for example, as far as system controlling in the sense of costing. But of course, you can use a model to, or you can annotate the elements in a model with let's say, economic information. For example, deriving a target costing approach from such a model, right? The model gives you the structure to maintain that. Depending on how you want to take it, you can of course incur further down the road. You can incur like cost estimation and pull them into the model if you want, or you can use a better suited, more dedicated tool for that and use just the model as a starting point. But we've used the model of systems as target costing blueprints, right? Because as we know, in a development point, in a development project, the focus on cost and establishing a goal very early on is something that's usually very necessary.
And then I would like to hand over for Viviane for some final closing words.
Thank you, Tobias. I think there are a couple questions left. Might provide an answer afterwards to that. But from my side, thank you very much for your participation. In case you have any more questions on that, feel free to contact us afterwards. As mentioned before, the recording will be provided to you as well as the presentation. So we are open up for any discussion afterwards, and maybe to wrap up the one or other question that has been addressed and not yet answered. For more information, as you can see here on our website, in the end, I only have to say thank you very much. And I wish you a nice evening and have a good time. Hope to see you soon. Bye.
Thank you. Bye-bye.